Okay, welcome back to the channel, everybody. Today we've got a pretty fun project. We're going to be making the tolerance test that I designed in CAD and did all the cam work for in the Carvera cam software. And we're going to be milling it out of this 5mm thick aluminum sheet. And as well as I want to test this EcoFlow Delta 3 Plus battery to see kind of what are the power draw as we're working through this aluminum, which is going to be kind of your worst case scenario on a machine like this. So stick around, it should be a pretty fun one. Alright, so I've gone ahead and I've loaded up my cam project, my G-code, and it's looking pretty good so far. I went through this and I watched the preview. It's looking pretty good. For this project, I'm going to be using just this one bit. It's the 3.175mm by 12mm flat end mill. So that's all we're going to be using on this project. Gonna make it pretty simple and easy to do all our drilling holes and everything. So we're going to go in and set it up. I've gone ahead and set the origin. We're going to use automatic bed leveling. I've changed the parameters here to basically probe it in a 3x3 grid. And so yeah, let's go ahead and run that. A quick run. It says to add the probe. So I'm going to go ahead and I'm going to actually remove this dust chute, so don't have to worry about that. All right. Now I probably should be using air assist on this one, but I haven't quite got that set up on my machine yet, so here soon hopefully I can get that working. I'm going to be watching this pretty carefully because that does get really close to that one fixture. So we're going to want to watch this pretty closely, but I've got my e-stop button there ready, and this is my first metal project, so I decided to do this one instead of the example project first, so this should be interesting. Okay, so that's interesting. Lights up 3 and then flashes the 4th. So it's asking for tool number 4 is what I've got it set up as, but okay, go ahead and okay, so I set the original initial height a little too high. So while it's just milling in midair, we're just gonna let that run, and I'm gonna show you guys the power draw. So it looks like right now it's averaging around 80 watts, and that's with the spindle on, and it's obviously not under any load right now, but I don't expect that to change a whole lot. You know, maybe like 100 watts when it's under load. So anyway, just thought you guys might want to see that. I'll bring you in a little bit closer here. So yeah, I mean it's really not a heavy load there. Alright, so here's an update. After it started milling into the aluminum, it's hitting into the 90s, but I mean, really, it hovers right around 80 consistently. Yeah, so it's not too power hungry, I guess. As you can see, it creates quite a bit of fine chips, fine little things, and I think I could have changed my parameters a little bit more to get bigger chips off of it than that, but this is my first run, so we're just going easy, light and easy. But I had to make a quick fix on, because this job is supposed to go, another hour and a half. So I decided to pause the job. I hit pause over there, and then I lifted up the lid, and I got my air compressor, and I adjusted the nozzle over on this side, the air assist, to line up with the bit, because I hadn't messed with it at all before that. And then I just get my air compressor. This is just a quick fix, and line it up there, and then I can just give it a couple blasts, and it cleans it out pretty good. So it's a temporary fix until I find a more permanent solution, but it seems to work pretty good. It's moved on to milling out this center part for the circle, and so far it's looking really good. Okay, so that part took about 37 minutes. Not too bad. It's a little messy in there. I didn't have the dust chute on, so it was not vacuuming anything up. I was just doing air. But looks pretty good. I'm gonna get it all cleaned up, and we'll take a look at the dimensions. Alright, so we've got the finished part here, and I'm using my analog, just the old dial calipers. I find that they work way better because I always found myself running out of batteries, having to always replace those digital ones. So I've switched to these, and I love it. Highly recommend it. But I've got my finished part here, and I know the dimensions of the outside here should be 1 inch, and then the known dimensions of these holes and this outer. Probably hard to see on the camera here, but there's a circle there, and those are all known dimensions. So let's take a look at this outer one first here. So you can see that's within 1/1000th of an inch that way. Let's flip it, and it could be a hair off because I had those two tabs, remember? So no, I'm getting about the same, 1/1000th big. So I would consider that amazing. I'm happy with that. On my Bamboo Lab carbon X1 carbon, I could achieve around like 3 to 5 thousandths of an inch tolerances. So pretty stinking accurate, but this takes it to another level there. So okay, so this one should be 0.4 inches, and you can see we're almost dead on, just a hair big. Let's just turn the part 90 degrees there. Well, let me get a better angle at it. You got within 2,000th there. Okay, let's try this diamond here. This is the diagonal one here. This one I found is probably one of the worst ones, but I think it's because there's a burr that it's catching on. So if I was to do this part over again, I would add a small chamfer to that, but just because I think it's catching a burr. But yeah, it should be 0.6, and we're about 5,000 big. So, okay, let's try these inside holes here. So we should be at 0.15, and we are dead on. That internal hole is on the money. Again, that other one, same. So these internal holes look really good, like really good. Let's try this main center one here. Get a better bite on it. About 1/1000th small. Oh, I don't like that one. There we go. Yeah, about 2/1000th small there. So all in all, I mean, I'm seeing on average, you know, you're talking within, oh, definitely within 5/1000ths of an inch, but more common is like within 1/1000th or two. So pretty awesome. This dimension I would expect to be really bad, just because it the automatic Z height, the way it probes that, there's not a super great way, unless I'm not thinking straight, but there's not a super great way to ensure that that's that perfect thickness. Similar, like how the X and Y, I mean, those ones can be very accurate. The Z, I would imagine to be the least accurate, but I mean, that should be 0.1 or 0.16, and we are dead on. So somehow that one, I'm gonna have to think about that one some more, but it's dead on. So all in all, I think this is an awesome test. I think in the future I want to maybe try 3D printing this and just see, just for kicks, what the 3D printer can do. But if you're needing high dimensional accuracy, I would highly recommend the Carvera Air, because it's going to produce parts that are spot on for most of your projects. So anyway, thanks for joining me on this one, you guys. I think we'll wrap it up here, but subscribe if you like this kind of content. I'll be doing lots more of this, especially with dimensional accuracy testing, and stay tuned, because upcoming I've got a tensile tester project that I'm going to be working on. So subscribe to the channel if you haven't already. I'd appreciate it. It helps the channel grow. And but until next time, have a good one.